Hi, this is Suresh. Welcome to Rock Tutors. Today, we are going to discuss a new topic, sign convention. This topic is very important to solve the numericals. Without sign convention, we cannot solve the numericals. That's why this topic is very important. సో ఈరోజు మనము సైన్ కన్వెన్షన్ అనే టాపిక్ గురించి డిస్కస్ చేసుకుంటాము. అలాగే ఈ టాపిక్ చాలా ఇంపార్టెంట్ టాపిక్. న్యూమరికల్స్ మనం చేసేటప్పుడు ఈ యొక్క సైన్ కన్వెన్షన్ని మనం అప్లై చేస్తాం. అప్పుడు మాత్రమే మనకి సొల్యూషన్స్ అనేది వస్తాయి, లేకపోతే మనకి సొల్యూషన్స్ రావు. అందుకే ఈ చాప్టర్ చాలా ఇంపార్టెంట్. సో ఈ వీడియోని స్కిప్ చేయకుండా మీరు ఫాలో అయితే ఈ యొక్క సెషన్ మీకు చాలా హెల్ప్ అవుతుంది. ఇన్ అవర్ సెషన్ విల్ డిస్కస్ లెన్స్ ఫార్ములా, పవర్ ఆఫ్ లెన్స్. దీస్ టాపిక్స్ ఆల్సో విల్ డిస్కస్ టుడే. ఈరోజు మనము లెన్స్ ఫార్ములా, అలాగే పవర్ ఆఫ్ లెన్స్, అలాగే మ్యాగ్నిఫికేషన్ వీటి గురించి కూడా మనం డిస్కస్ చేద్దాం. ఇన్ ద ప్రీవియస్ వీడియోస్ వి డిస్కస్డ్ అబౌట్ లెన్స్, కైండ్ ఆఫ్ లెన్స్, ఇమేజెస్, kind of images, and ray diagrams, and also characteristics of the images we discussed in the previous videos. So please go through those videos also. It will help you to understand the concept clearly. Without delaying, we'll go into the topic. Our topic is sign convention. This topic is based on Cartesian plane system, a Cartesian system. We know that the Cartesian system, we have a Cartesian plane. In the Cartesian plane, we have a x-axis and y-axis. This is x-axis and the vertical axis is the y-axis. So this is origin, where these two lines are meeting, x-axis and y-axis. This is called a origin. If you move towards the right side of the origin, you will get positive signs, positive numbers, positive values. If I am moving towards the left of origin, we know that we will get negative values. If we move above the origin, above the x-axis, maybe above, if I am moving above the origin, we will get positive values. From moving below the origin, we will get negative values. This is basic information about Cartesian plane or Cartesian system. Now we will discuss about sign convention for convex lens. We keep the object every time on left side, so that it is easy to apply the signs of the Cartesian plane. In this topic, we will learn some more technical terms. One is that object distance. Object distance. We take u as a object distance and image distance Image distance will take as a V, and focal length will take as a small f. Object distance U, image distance V, focal length f. For size of the object, we'll take a size of the object, we use HO. H for height, O for object, HO. Size of the image, we'll take the height of the image. This is a HI. So these are the terms we use while solving the numericals. Now we apply sign conventions for these values here. Okay, now we'll see one by one how we apply signs for these terms, these values. The first point we have to remember that we take object always left side. మనం ఎప్పుడు కూడా ఆబ్జెక్ట్ ని లెఫ్ట్ సైడే ఉంచుతాము. Now we know that already we discussed in a Cartesian plane. From origin, if I am moving towards the left side, we will get a negative values. If I am moving towards the right side, we will get a positive values. If I am moving from origin to upward, we will get a positive values. If I am moving origin to downwards, we will get a negative values. So here, the same thing we apply here also. The second point is whenever we are measuring that distances, we have to measure from origin. We have to start from origin. That means we have to start from O. We have to measure the measurement from optic center. So here this is optic center. Suppose I want to measure the object distance. That means object distance, this is the object. The distance between optical center to that object, this is called a object distance. Now here, this object distance OB, not BO. So you can say that, sir, both are same and as for both distances are same. BO or OB both are same. But here, so when I am taking a BO or OB, here the directions are changing. That's why so we have to start from optical center. This is the, from here only we have to start. If I measure that image distance, I have to measure from, I have to start from optical center to image. This is the second point. Now third point is very, very important. So when we apply the signs with respect to the incident ray, with respect to incident ray, we apply the sign conventions. Now here, you know that this is the object. From here, the rays will be comes. Now here, from A, this is the object. From here to this direction, that the rays are coming. This is the incident ray. So now here, if I want to measure the object distance, then here I will start from optical center. Optical center to B. Now I am moving from O to B. Observe here. So then this incident ray is this direction, and this I am moving from O to B. I am moving opposite to incident ray. So when we are moving opposite to incident ray. So what happens? Then when both are opposite directions, then that time we'll take as a negative sign. We'll take as a negative sign. Now here, in this case, I want to measure object distance. Means, so I will move from O to B. So O to B, just now we discussed that the image, so object distance, we denote with letter U. So this is U. Now tell me which sign for this will give. So here I am moving here, both are in opposite direction. So both are opposite direction. This incident ray is going this direction and I am moving from O to B. Both are opposite. Opposite means we will take as a negative. Now here object distance is negative. U is negative. Now here, if I want to measure that image distance, it also I have to start from O to B. B1. So O to B1. Now here, if you observe here, so I am moving O to B1 and that incident ray also both are same direction. Both are same direction. So that time we will take as a positive. Now here, in this case, image distance we will take as a image. This is the image distance. Image distance. So we use the letter V. Now this sign will give this one positive. Why? Because both are same direction. This is a positive. Understood? Now here for this, AB is a size of the object. Means height of the size means height of the object. Otherwise length of the object. Here this is above the principal axis. Above the principal axis means above the x-axis. Always positive. Now here above the principal axis I will take as a positive. Here I will take this as a HO, height of the object. The size of the object HO is a positive. Now here in this case, this is the image. So size of the image means height of the image. Here I will take this as a HI. Now this is below the principal axis. Now below the principal axis, this is below the horizon. We will take as a below the horizon. So below the horizon in a Cartesian system is a negative. So here also below the principal axis, negative. So HI is a negative. This is the way we apply for this convex lens. Now here we know that if you observe here in a convex lens we will get two kind of images, real as well as virtual. So now this is real image, that's why it is forms below the principal axis. So here that image, height of the image always negative. For real images, height of the image is size of the image is always negative. Now suppose this is forms a virtual image, then what happens? Now here suppose I kept here this object between optical center and F1. You know that we will get that image. This is the image. In this case, so this is a virtual image. This image is above the principal axis. For this case, height of the image or size of the image is positive. This case, height of the image is positive. Remember, that means for virtual image, always they erect and forms above the principal axis. That's why all virtual images all are positives. We'll take a positive sign. Height, size of the image will take positive for all virtual images. Next one, the last one, the important one, focal length. The focal length, now here, so focal length optical center to f2. This is the focal length, f. Now for this focal length, we'll take as a f. Then here f is a positive. Why? Because here both are moving same direction. So f is a positive. Focal length is positive. So here for convex lens, focal length always positive. Note this point. For focal length, for convex lens, focal length always positive. Now here, object distance always negative. Object distance always negative. These are the 2 points you have to remember. So we apply this sign conventions for concave lens. For concave lens also, let's see. This is the incident ray. We want to measure the object distance. You know that this is the optic center. You have to start from optic center to object. This is the object AB, image A1, B1. Object distance means optic center to object. So here O to B, I am moving this direction. So both are incident ray and the distance from O to B, both are opposite direction. So we'll take as a negative. Here U is negative. From here to here is a U is negative. Now here, this is the image. So I want image distance. Means here, image distance. In this case, from O to B1. O to B1. So I am moving. This direction is opposite to incident ray. So when both are opposite, we will take as a negative. For this case, from here to here, this is the V. V is a negative. In this case, both are negative. Now what about size of the object? Size of the object means this is the size of the object, that is the height of the object. So this is above the principal axis, we will take as a positive. So here HO is a positive. And size of the image, this is also above the principal axis. So this size also positive. So HI, height of the image, is positive. Now what about focal length of concave lens? Now here, this is the focus and focal length we measure from O to, so everything O to F2, O to F2. Here also I am moving opposite to incident ray. So both are opposite. So here this OF2 is a focal length. Here both are opposite, so we will take as a negative, minus F. Now for concave lens, what we observe? Here focal length negative, and image distance negative, object distance negative. Only height of the image and height of the object both are positives. Remaining three are negatives. So this is about sign convention for concave and convex lenses. Now we'll see lens formula, derivation of the lens formula. This is not in our syllabus, but we will derive how that lens formula it came. For lens formula is that 1 by f is equal to, lens formula is 1 by f is equal to 1 by v minus 1 by u. 1 by v minus 1 by u. This is the lens formula. How we will get that formula? Okay. For this, I am taking in this diagram AOB, triangle AOB, and also one more triangle A1OB1, this triangle, these two triangles I am taking. Triangle AOB and triangle A1OB. These two triangles are similar. You know that? So this angle and this angle both are 90s. And this angle is equal to this angle. Vertically opposite angles. So then these two triangles are similar triangles. When triangles are similar, we know that their corresponding sides are proportional. Now here in this one, this side and this side, AB by A1 B1 is equal to OB by OB1. Equation 1. Now, in a second triangle, I am taking one more triangle. In this one, DOF2 and A1 B1 F2. These two triangles also similar. A triangle DOF2 and triangle A1 B1 F2 both are similar. Triangle DOF2 and triangle A1 B1 F2 both are similar. Then their corresponding sides are proportional. So here OD by A1 B1 is equal to OF2 by F2 B1. Equation 2. We know that here OD is equal to AB. Both are equal heights. So because these both are parallel, so OD is equal to AB. Here OD is equal to AB. If I substitute OD in this equation, we will get it AB by A1 B1 is equal to OF2 by F2B1. Equation number 3. Now, AB by A1B1, AB by A1B1. So here from 1 and 3, we can say that OF2 OB by OB1 is equal to OF2 by F2B1. So from 1 and 3, you can say that OB by OB1 is equal to OF2 by F2B. Here OB means this is. Here OB is equal to, OB is a object distance. If apply the sign convention, it will become as a minus U. OB1. So this is OB1 from here to here. This is a V. F2B1. Here F2B1 is equal to, so this distance is equal to V minus F. F2D1 is equal to OB1 minus OF2 is equal to V minus F. Now these values substitute in the equation 4, we'll get it. OB minus U by V is equal to OF2 F by V minus F. Now if you solve this equation, this one, and cross multiply, you know that become as a minus U into V minus F is equal to VF minus UV minus into minus plus UF is equal to VF. Now this equation dividing both sides by UVF, then become as a, so minus UV by UVF plus UF by UVF is equal to VF by UVF. Now here UV cancel, and here UF cancel, here VF cancel. Now we'll get it, minus 1 by F plus 1 by V is equal to 1 by U. Now it becomes as a, so minus 1 by F is equal to minus 1 by V plus 1 by U. For take a minus common, this one, minus 1 by F is equal to minus 1 by V minus 1 by U. So minus minus cancel, 1 by F is equal to 1 by V minus 1 by U. This is our lens formula. So this is applicable for concave lens also, the same man. So lens formula for both are same, convex and concave also. This is the lens formula, 1 by F equal to 1 by V minus 1 by U. Next point, magnification. M is equal to length of the image by length of the object. Length of the image by length of the object. So I am taking a length of the image I and the length of the object is a O is equal to V by U. So magnification, length of the image by length of the object. So I by O is equal to V by U. Now see here in this diagram, triangle AOB and triangle A1OB1. These two triangles are similar triangles. So when triangle AOB similar to triangle A1OB1, triangle AOB and triangle A1OB1 both are similar. When both are similar, their corresponding sides are proportional. So A1B1 by AB is equal to OB1 by OB. You know that here we apply these values. A1B1 is a image. A1B1 is equal to image. You know that image sign convention is a negative. So minus I. AB image, AB height of the object, the size of the object. AB is equal to, I am taking as a O, is a positive. So now OB1, O to B1, this is a image distance. So here image distance, we know that, so both are the same direction, incident ray and image distance, both are in the same direction, so we'll take as a positive. So here OB1 is equal to V. Now OB. So here this is a OB is a object distance. We know that is a negative. Now here OB is a negative. Is a minus U. Now substitute these values in this equation. We'll get it. Minus I by O equal to V by minus U. So here minus cancel. I by O is equal to V by U. This is a magnification. So magnification equal to I by O is equal to V by U. If magnification M is greater than 1, then that image is magnified image. If the magnification is less than 1, that means that image is diminished. small size. If magnification is equal to 1, then the size of the image and size of the object both are same. So this is about magnification. Power of lens. So power of lens means incident rays after refraction, how much angle they deviated. That means angle of deviation is called a power of lens. Now the unit of power of lens is diopter. The symbol we use for power of lens is D. For a thin lens, you know that a thin lens, the focal length is less. Then that angle of deviation will be more. The angle of deviation will be more. So then the power of lens also more. For a thin lens, focal length is more, then angle of deviation will less. So power of lens is less for a thin lens. Now we can say that, so power of lens D is equal to reciprocal of focal length. Now here 1 by F. So F is in meters. So focal length is equal to 1 by, power of lens D is equal to 1 by F in meters. This is important. And next point, power of lens for convex lens D is equal to 1 by F is a positive. You know that for convex lens, focal length, sign convention is positive. That's why, so for a convex lens, power of lens is positive. For concave lens, this is for convex. For concave lens, power of lens is 1 by minus F. You know that for concave lens, focal length will take as a sign convention minus, negative. So here 1 by F, so D is equal to 1 by minus F, so this is a negative. Power of lens of a concave lens is a negative. Now here, suppose I am taking combination of lenses. If I took more than one lenses, so then what is the power of that combination? Now the power is equal to algebraic sum of individual powers of the lenses. Suppose I am taking two lenses together. This lens power is 3D, this lens power is 2D. So then total power is equal to 3D plus 2D is equal to 5D. This is the combination of power of the lenses. Suppose I am taking two lenses. Suppose this power of this lens is 3D, I'm taking one more lens, is a concave lens. This power of lens is minus 3D, then the total power of lens is equal to, power of lens is equal to, we know that 3D minus 3D is equal to 0. Then power of lens of this combination is 0, means this combination behaves like a glass slab. So when these two are a same power of lenses, the powers both are same, so then these two behaves like a rectangular glass slab. This is about the today's session. We discussed in this session about sign convention and how we apply the signs for the values, and also power of the lens and magnification of the images we discussed. And also we discussed that when magnification, so how that magnification changes. If that value is, the m is greater than 1, means that image is magnified image. If that m is less than 1, then that image is diminished. If the m is equal to 1, then that image is equal to, the image size equal to object size. These things we discussed in today's session. I hope you understand this chapter, and we'll see in the next video with a new chapter. Thank you for watching this video. Have a great day.